Mirmi, and they know each other very good. And I'm glad to have you here. So please take a seat, and we will spend some. We will spend some minutes.
You want us close or far? What's more convenient for you?
No,
close.
Please,
right?
close.
Close. Yeah.
Close. Yeah. So we will spend some minutes in discussing the future of robotics, and first we will discuss in English. If you are German speaking and want to follow it in details, we have a simultaneous translation. If you need some, just go and get you some earphones. So, thank you very much. I'm very glad I have you both here, and I want to open our discussion with the question. So, as Torsten presented, an open platform for robotics, and there are other companies showing open platform style of products. Speaking of building the Android or the Windows of robotics. So, what do you think? How important is an open platform for the future of robotics? Maybe Sami, you want to start?
Sure, more than happy to do so. So I think Torsten did already a great job in explaining let's say the perspective for the next years. And I think what you're doing is an amazing job in the sense of trying to make programming easy and don't go into the details of every single robot system, I guess, right? And since Brian is here, and I see Julius and also Tully and all the folks from back then from Willow Garage, these ideas of open platforms, I think, was born, at least on a larger scale, in the robotics community around that time. And I think from the scientific community, openness has always been a very strong kind of, let's say, desire. Why? Because not only sharing is caring, but in particular, by sharing you can increase the knowledge and the acceleration of knowledge discovery, you could say. So I think this has been established in the robotics community very, very strongly. So we believe in that. But we also have the challenges. Torsten was not only talking about manipulation, that's one, but also the different platforms, right? If you think not of robots only being manipulators, already there it's very complex, but we see robots that are, quadrupeds, walking dogs, right? Boston Dynamics types, humanoids in the future, and so on and so forth. So I think this is extremely important because our field is very complex, very challenging, and we need more than just one lab or one, bigger company that can solve robotics. It seems to be a bit harder than, telecommunication.
Okay, maybe for your first statement, what's your vision of open platforms? Maybe only not only with you on Intrinsic, more on the research and the technology market.
I mean, one is I really believe that the utility value that is being created will happen more and more in software and in the future even more and more so in data. And therefore, looking at ROS, for example, there are a number of components that are missing for an industrial deployment. And looking at things like certification for security to make sure that data is securely transported. Same is true for over-the-air updates, for example. Then privacy, especially here in Europe, is going to be really, really important to make sure that, be it a developer, be it an end user, that there's a holistic concept for data privacy that is being offered. Safety is another one when it comes to control. And these are things that are fundamental if you want to launch a product in this industry. Now, from a software perspective, actually, I had a fantastic conversation with one of our board members, Anil, who's sitting in the audience as well yesterday, looking at what is the right level of granularity of abstraction layers and APIs. If you have too many, no one is going to keep an overview, and it's going to be too complex, it's going to be very, very messy. If you have too few, you're not flexible enough to do what you actually want. So finding the right level, the right abstraction layers, and maybe to some extent looking at what's happening in nature. Like, we humans are not controlled end-to-end. We have like several abstraction layers in our body, starting with our spinal cord, there's the cerebellum and so on. And then building that into the heart of the software platform so that people can use these APIs and then extend the system with the things that they need for their application, for their robot, for their hardware.
So maybe just to comment on that, I think what Torsten is describing is very fundamental for I think you and Siemens, you're talking a lot about IT and OT. I actually now understand, I guess, a little bit what this means. So I think this combination actually makes it important that in the modularity and in the openness, if you want to have that in control systems with feedback loops, right? This is kind of where you're coming from now. Everything gets much more challenging, and it needs to be much clearer because it comes with safety, stability, robustness, and so on and so forth. And if you want to do, let's say, machine learning in the loop style, not just get data from, let's say, it falls from heaven. We don't know where it comes from, but it comes, and then do processing, and then the robot uses it. This is not how robotics works, right? Robotics has to be in the loop, whether it's in simulation or whether it's in real world. So I think this is extremely important because the modularity and the openness, they actually have direct impact on the safety, integrity, and performance of the systems. So it becomes a much, much more complex problem than a pure pipeline problem like you have in standard deep learning at the moment, or communication technology most of the time. So, and this is why it's so challenging and why it's so important to solve that.
Maybe another challenging point could be, is the robotics industry, like the big players we're seeing here, ready for open platforms? You know, like the guys from KUKA and FANUC and ABB and Yaskawa, or you name it. They're very happy and they have their own ecosystem. And how do we get them to this point?
I'll let you go first.
You guys, right? We've got the big pull here now. You remember we had a CEO roundtable two years ago, right? I think, and we had a CEO roundtable with, I'm not sure you saw it, but there were, I think, all the big four were there, and it was interesting. We had this question. Ken Fui was asking that question, and it was an interesting reaction because I was trying to say, guys, can we do it? Because we all want to use the data for machine learning in the loop, and I think. Many discussions have happened and there's progress. And if I understand correctly, you're doing a collaboration now with Comau, right? So there's a robot manufacturer that seems to be very interested in that. And I'm sure many are talking with you guys. And together with Siemens, I think that's a strong pull that could be created. That would be my stake on it. I don't know how your internal discussions go, but I hope they go well. Right.
So maybe to frame this slightly differently, what we actually intend to provide is a framework that people can get value from. And looking at the existing business models, people will not use our software if there's no advantage to them, if there's no advantage for the end user. And maybe one way to think about this is what is going to be the value for the end user that is being provided. And if there's something that we can provide there, I'm sure that there's going to be interest, but we're not going to be forcing people onto an intrinsic flow state. We want people to come because they want to come because there's added value using the components that we offer and that also third-party developers offer on the platform.
But I think the question was not to use flow state or not, right? It is even more broader, I think. That's the great thing. I think the question is a little bit, how do we get to a data economy? Yeah, it's much, much bigger than single tool questions. So I think the value is one thing, but also, again, if you want to go to machine learning, whether it's perception, like computer vision based or tactile based or any kind of sensors, I think the value will come because otherwise it's very hard to run these super complex systems, right? Just using a monolith that is supposed to solve everything. In Germany we say the eierlegende Wollmilchsau. Yeah, this is apparently quite hard and tough. And it seems that for robotics, this is not solvable at the moment. Maybe in 40 years, we don't know. But I think in order to really leverage the many things that are there now, and the machine learning revolution, the revolution in robotic generations that has happened the last years, connectivity, 5G, coming 6G, I think it's extremely important because it's cyber-physical network systems, which is more than just one single box on a robot. So I think this is rather a necessity than forcing someone. There's so much potential behind that.
So I agree with that, but I would like to again put the customer in the focus. Like if a customer is willing to provide the data, why would a customer do that? Like let's say we would talk to one of the big automotive players. Why would they give the data to Intrinsic or to any other company? Like it doesn't have to be Intrinsic. They would certainly only do that if there's an added value, an added benefit. So one example, for example, is if you, this can be any like data analytics provider using any platform. Let's say they provide the data, and based on that data, you can increase the cycle time or the throughput of manufacturing, let's say by 5%, by 10%. I'm sure that from an end user's perspective, if I can increase my production by, let's say, 10%, I'm sure many people will be willing to provide the data if there's the benefit. But people will not provide the data for the sake of providing data. So there needs to be an added utility value if people do that. And this is to your point, Sami. This is key to provide that, to get to that ecosystem. And that will take some time. That's going to be a journey that will probably take a few years. But I'm quite convinced that we will see more and more of those cases where there's added value that is being created through data collection.
Yeah, in a way, what's happening here is, I think, intrinsically we are kind of trying to move towards what we call robotics as a service, right? So, and if you want to provide robotics as a service where you can package a solution and not components that you have to assemble yourself, I think it's ultimately the solution to use all these technologies, and then the data becomes the necessity. So, what do you mean by value is, I think, even a concept that really is about to change robotics on a large scale. So, because I think the main point about using robots is not that you want to use a robot, you want to get a problem solved, right? You are a manufacturer. So what do you manufacture? And if you want to do this at large, let's say large scales, the throughput is only important, that's one dimension. Then the other one is the flexibility is important, and then the accessibility are important. So and I think if you can span these three dimensions and you can get the sweet spots, then, as Torsten was saying, data becomes important, because otherwise you will not hit these sweet spots. But I think this is very clear that this is happening at the moment, right? Whether it's this year or next year or in 10 years, we never know. We talk about Industry 4.0 when I was almost still a PhD student, I have the feeling. So I think it's kind of repackaging the same statement over and over again, but we're getting there. I think this is clear.
When we look into the future, like 5 years or 10 years, do you believe on the vision of there is an Android of robotics or there's a Windows of robotics? What do you think? Will we have in robotics a future of like it is in the smartphone? Maybe we have an Apple-like ecosystem, very close but very user-friendly, and a larger open world, do you think? Or will we have a fragmented world with all the operating systems staying there?
Diversity is a good thing in a way, right? And it's also a limiting factor. So it's a very tough question, because it depends on how many, killer applications are there and how do they scale. So the past is not always the best, predictor. We know this in machine learning, right? Especially if you want to generalize to unforeseen future, it's not always good to look what happened yesterday to predict what happens tomorrow, right? But let's assume that there will be. I would actually, if you would ask me where would I put my bet, I would say there's going to be more and more unification on the software level, because otherwise the scaling will not happen. I wouldn't say it's robotics because robotics is huge. It's much more than little arms. It's everything in the future, right? So if we say for industrial robotics, I can see a lot of potential for that. Yeah, I would be also happy if this happens, that we can really have a kind of a hardware abstraction layer. I was proposing this 10 years ago to say, why don't we get to a hardware abstraction layer where then people can really use robots like a utility basically, and in their overall problem solution. So I would be very glad to see that. Having said that, I also believe there's going to be standalone solutions, and in the research, it's harder to say we standardize. I think this is not really going to happen. Yeah.
And are you confident building with Intrinsic like an Android of robotics as Intrinsic itself, or do you think it's more like an ecosystem style of going to the things?
Let me start with a personal comment. When I joined Intrinsic, I did it with the goal to help the community at large. And I believe some people who know me well, this is what I have been trying to do over the past 20 years. And this is also one of the key motivations to work at Intrinsic. And I very clearly believe that the software play, and then from an ecosystem perspective, is something that will add value, that will help the field moving forward. And I would actually say when you look at robotics at large, not only robust industrial robotics, this is sort of a starting point, because here we're seeing environments where that are structured enough that AI methods can add value, and where the hardware is mature enough that they can actually add utility value in applications, and also new applications that are maybe not possible today that we will see in the next couple of years. I would not see a reason why you cannot use the same software ecosystem then for other verticals as well. Maybe even for other embodiments, like you mentioned quadrupeds. Exactly. Because the structure, the software structure is not necessarily different whether you have a robot arm or two robot arms, a quadruped. Of course, kinematics and dynamics are different, but therefore we have interfaces. This was the piece I tried to convey earlier, that having the right abstraction layers so that people with domain knowledge can actually add their domain knowledge, and if this is, let's say there's IP involved, they should keep that IP themselves. This is not something that a platform player should claim. I would even say from a platform perspective, there's no way that any player, not even Alphabet, can have all of the application domain knowledge in-house. So it's very important that IP and domain expertise stays with the developer, stays with the users. I do believe, though, that providing a framework with infrastructure, all of the things I mentioned earlier, will help accelerate the field to implement more applications faster so that people can use and leverage more robots.
So would you actually say we shouldn't standardize robots, but rather skills that robots can basically fulfill? Because in a way, this would be the consequence, right? If you want to have the right abstraction layer, let's say it's a quadruped or it's a mobile robot, and you want to have a, fetch me the bottle, fetch me the beer, right? Fetch me the beer from the fridge. Then, in order to maintain that, you would need to be able to abstract on that level and not on the lower level, I guess, right? Because then the quadruped, the dynamics, and it would be otherwise meaning that the central nervous system of a human would be the same as for an elephant, right? Which I know we agree on that. So obviously. Yeah. But on which level are we talking? And are we actually talking on the robot level or rather on the skill level, which comes from the process you want to automate?
I would say both. Very, very clearly both, in the sense that let's start with the robot level and then we come to the task level or to the skill level. To have a hardware abstraction layer so that you can use actuators that you need for your robot. Maybe you want to build a low-cost robot and you have like cheap actuators, or maybe you want to have something very fancy with...
And how does the software know that it's a robot that has not these capabilities? So let's say it's the same robot, but with, I'm not sure cheap, let's say reduced performance, let's call it this way. And how do you see this bidirectional system? So
let me give you a few examples. Really, again, coming from the robot, if you think of position-controlled robots that you can see here, we can already show today that you can transfer skills from one robot to another, even if they
behave the same, right?
Exactly. They have the same very similar kinematic structure and typically the same dynamic behavior.
Exactly.
When it comes to, let's say, even torque, you are the expert in that. And when it comes to torque-controlled robots, if you, let's say you pick a Franka, you pick a KUKA, you pick a Dosan, pick any robot, any torque-controlled robot here, the dynamics are already slightly different. And that also means that transferring a skill from one robot to another is in many cases possible, but I would already claim not in all cases. However, coming now to the task level, what you were describing, let's say I get the instruction to move one glass from here to the other side. And now I with my amazing human skills, I can infer. I first need to grasp, I lift it up over the bottle, and then I set it down until contact, and then I open it again. On the task planning level, and I would even say on the motion planning level, this is something where you can abstract across,
I agree, 100%,
across embodiments. Yeah.
But I think there's still kind of this, and I'm not sure there needs to be a solution today because we are not there yet on the algorithms level. But if you think about it, that there's this movie. It was with about avatars, where you could have, depending on how much money you had a very tactile avatar with Bruce Willis, I think it was, or a very clumsy avatar. So you had no sensation of the world. So you could almost not open a door. This is where my key idea came from, because the avatar had so clumsy hands that he had to use 2 hands to grasp a key and put it into the lock, open it, and then open the door. So I think this is something where we need to have a kind of a community effort to understand really the embodiment and the task. They are coupled. Very and quite dramatically, the more you go away from pure kinematics, the more you come to these, interaction, manipulation, everything that is contact-based. I think we see that there is something, at least I feel, is still unsolved fundamentally, right?
I fully agree. And I'm totally not claiming that you can have a task description or even, let's say, a set of skills that are implemented, let's say, for a position-controlled robot arm, and then suddenly you have a humanoid or a quadruped with entirely different dynamics that you suddenly can transfer the skill. Even, let's say, if I would take my human arm and suddenly I would put it next to my hip, I'm sure that my brain would be totally confused for quite a while, and I would need to relearn many manipulation skills because I'm used to having my right arm here and not at my hip. But we humans are so adaptable.
Somehow,
we can learn that.
Absolutely.
But it will take time. So and clearly in robotics, we're not yet at a point where we can magically say, hey, you can implement it for this kind of embodiment, and it will automatically work for that kind of embodiment. So I believe that works on a semantic planning level. Like I said,
because it becomes a task, right?
Exactly.
Rather than the robot.
Yes. And then how you then convert the task plan into a behavior tree of skills.
Exactly.
Yeah.
Absolutely. Yeah, that's fantastic. Just if I can make one more question, because he was saying something super interesting. So humanoids, so there's a big elephant in the room, which is the humanoids from Tesla, right? So because you were asking about Apple or
Android,
Android. So what is your feeling about that? I mean, it's quite dramatic, the progress they do, right? So, but what do you think of this approach to say we own the whole stack? Because there seems to be a very different decision than you have been doing at Intrinsic to say we need to build robots in order to do AI, and this is kind of very openly claimed. So how do you see that? I mean, there was a video I think 3 weeks ago, which was much more, I think, interesting compared to what we saw 3-4 months ago. I think I'm not tracking this exactly, but how do you see that? I mean.
Let me give you 2 answers. One is to tie it back to the software ecosystem conversation we just had, and then the second one on humanoids. So from a software ecosystem perspective, I don't see any obstacle to, let's say, take any controls framework and then also run it on a humanoid. I mean, the question then will be, does your control system allow a floating base? Like looking at Boston Dynamics, when you hear Mark Rabert talk, he says the robots are constantly falling, and then they're generating steps in order to prevent from the fall. And from coming back to hardware abstraction and so on, I don't see any reason why that's not possible. And I would even say I'm very, very confident that this is easily possible. My second answer, for all of the tasks that I have been seeing from those companies, I believe you can, specifically looking at industrial environments, given that we're here at Automatica, you have a flat surface. Why not take a wheeled robot where you can put a large battery in, put 2 arms on top, and you actually get the same, if not better, performance, and you have way more battery power, longer lifetime. I don't see the reason for having a biped system in environments where you also have humans working. Plus, safety will be much easier if you have a wheeled robot. Otherwise people might push them over, and maybe there's a small child next to there are just many complications that come through humanoids. At the same time, there may be applications, be it in nuclear power plants, in maybe military applications, space applications, where you benefit from a biped system, and there might be a very good path forward for that. But I do believe for industrial environments, I'm not sure whether you need a biped system. But it's actually more about biped versus wheeled.
Well, I mean, I think the question is also, let's cut the biped for a second. Maybe the question is also, I mean, when you build robots and you do software and all these things together, it's always very clear that if you have everything in your hand, it's much easier, performance goes dramatically up. If you modularize, then typically it needs to be a pretty good design to get the best performance. So what's the reason to build a robot and do the control and the AI versus to do this the platform idea? So what is the promise that is behind that, also on performance level? Because in the end, I think let's do the hypothesis that a bimanual system, it doesn't have to be mobile, is doing something in the factory floor, right? So there seems to be a reason why building robots and doing the software.
Yeah. A fantastic question. This is almost the conversation. Do you have a horizontal approach? Let's call it the Android approach. I don't think it's the best analogy, but let's call it the Android approach versus the Apple approach, where you have hardware and software fully integrated. From a software perspective, let's say you provide such an ecosystem, it's very important that you provide interfaces where you can add, let's say, ARM-specific or robot-specific controllers, robot-specific dynamic models to get the very best performance out of the system. If you don't have that, obviously you will not get to the same level of performance as with the Apple approach. But think for just as one example out of many, think of maybe small robot vendors that might not have the resources to afford a large software development team, but they're really good at their hardware. They really exactly understand the mechatronics. And then looking at, hybrid control, adding multiple sensors to it, adding AI to it, safety, security. If they would be empowered with a framework so that the plumbing is already done for them and they add the pieces that they are good at, I do believe that there's a huge utility value add for those players.
Yeah.
For all the challenges you mentioned, how far is AI a problem solver for all of that? So is it a holy grail? So you put AI into the robot and it gets intelligent and flexible and can solve?
Yeah, that's running. You see it? It's the intelligent robot running around there.
So I think we need to look at some of the more nuances here. AI is a buzzword, and what we're actually seeing the progress is machine learning.
Exactly.
And if you now look at machine learning, what we're now seeing, especially, for example, with large language models, foundation models, they are already today amazing when it comes to task planning, to motion planning. We're now seeing the first really fantastic results for mobile robot motion planning already today, and I'm convinced that it will be less than 3 years until we see that in the productized world. When it comes to perception, like visual perception in particular, very similar. I'm very convinced that this will not take another 5 years. This will happen in less than 3 years. Where we're still seeing challenges is really physical manipulation. And the reason for that is, for these large language models, you need large amounts of data, and you need high quality data that is very diverse. And for the first two things I mentioned, task planning, motion planning, and perception as a second, you can generate that data synthetically, and it transfers very well to the real world. That's not the case for manipulation tasks, where you get in contact, where maybe also safety, physical safety plays a role. So here we still have a challenge. That I'm sure that what we will see is there are a couple of things that are more bespoke that will add value in the near term, and probably also in less than 3 years. Getting to something that is fully generalized is probably a little bit further out. I don't want to say whether it's 5 years or where we're going to be there, but we do have some challenges to solve there. At the same time, I would like to add, looking at the pace of the AI field at the moment, just as one example, looking at GPT 3.5 and GPT 4, there were a couple of months between the two releases, and there was a significant performance boost. So I would not be surprised, taking that pace into account, that we will see a significant impact in the next 1 to 3 years already.
So what's your view on that?
Yeah, I think it's I can only add to many of the things that Torsten said, but also giving hope to the manipulation problem, because I think there have been tremendous breakthroughs recently. So I'm glad to report these things. So obviously it depends on what you want to do. Mobility, I think it's clear. interaction is now what's coming, because we can now start talking to robots in a way that is not only annoying, right? It becomes useful, it feels. I'm not sure about the industrial environments. There's still many challenges, right? There's lots of noise and so on and so forth. So there's still very practical problems, but I agree. I think this is really happening and coming. Programming, there's a lot of, I think there's going to be a lot of recommendation systems and skill supports. But what I think is really important is in the manufacturing world, I mean, manufacturing comes from the Latin word manus, right? Hand, the hand. So we want to build stuff, right? That's what manufacturing is ultimately about. So manipulation is the holy grail of manufacturing, right? Obviously. So, and I think what is clear is, as you pointed out, Torsten, we cannot, or we don't have a lot of data, right? Why? Because first you need to succeed to create the data. So how do you resolve this chicken and egg problem? And I think what is the solution is probably not just to use data-intensive algorithms, machine learning algorithms, but to really the next generation of algorithms. And I think what we have shown, and it's actually already now shown at Automatica this year, is that you can do micrometer tolerance processes at high friction. You can learn on the spot, right? So insertion processes for electronics manufacturing, you can learn them. We actually showed on some of our exhibits, and not because you use a lot of data, but because I don't want to call it smart data. I think it's more smart algorithms. So an algorithm that, a little bit like this idea of the transformer models, you capture in the algorithms the essence of the problem, and then the learning becomes easier, and the transfer becomes possible. So I think this is already happening. It is not yet there where, I guess, NLP systems are. Large language models have made this tremendous process, but it's now at an industrial level and at the cycle times that people really need. So I think this is actually happening, but obviously at a different paradigm, which is not just lots of data, train, and then use it, but actually make the smart move and try to leverage also models together with the data approaches. Yeah?
If I can add one thing to that, that's absolutely right. And the solutions you mentioned on the manipulation side, these are exactly the bespoke things I mentioned. They're happening now.
Yeah.
It's not in 5 years. This is coming much sooner. Another piece that I believe will play a role is actually language itself. And I'm really thinking of language as an interface, obviously between humans and machines. But we're already seeing on quite some research papers, some of you might have been to Core last year, using language as an interface between software components.
I think that was us actually. Yeah.
Sorry?
We did that with Microsoft together to use large language models to program directly the paths of the robots, so that you increase safety, for example, right? That's kind of what you're
and explainability.
Exactly.
Yeah.
So people can directly program very complex paths, which if you use an AI system, you cannot program it, right? You cannot interface with it. Exactly. Yeah. That's a very good point, I think.
As you mentioned, you do a lot of exciting research at MIRMI and others. How do we get this research into the industry, and maybe especially into the small and medium businesses?
That's a tough one, right? Because I think it's what we're trying to do. So I have multiple answers to that. One is that cutting-edge science doesn't have to be contract research, but collaborates very intensely with industry. So we at TUM, and in particular at Munich Institute of Robotics and Machine Intelligence, we are very closely collaborating with industry, also on the strategic level. So for example, I see Edward Krubasik is here, who is the head of our industry advisory board, former member of the board at Siemens, and has been, a very trusted advisor and mentor to really assemble this amazing group of people that make sure, in a way, by good advice and intense collaborations, and this is people at C-level that really work with us so that our strategies align with what society and industry needs. That's one thing, right? Because universities typically are hundreds of professors that all do their thing, and then you have to find someone who by accident does something that means something to you as an industrialist. So we're really trying to be mission oriented there, and this is something that we really do. We have this support and collaboration with Messe München, which is called the Munich Eye, right? There's a high-tech summit, there's a Robothon, but also there's the AI Society, where we show our collaborations projects and also the collaboration with startups so that we can really show the translational aspects of our work and get the feedback from industry, but also healthcare and others to do the right thing in the scientific fundamental questions. So we try to get the questions that matter. That's the first answer to what you're kind of implying. That's the first thing, right? There needs to be something that makes sense. Okay. Then you need the support by the government. We as science and industry needs to be linked. So we have the strong Bavarian government supporting our basic science, but also translational aspects. I think Markus Blume, the Minister of Science, was giving yesterday the number of more than 4 billion, which they put into the Bavarian ecosystem. I think $1 billion into AI and robotics, into many of the things we're doing on Bavarian scale. And last but not least, which I personally think is still missing, but we need to work on that, is where is the next big OEM in Germany that we can develop? So we talked about this before, that if you go to the Dow Jones, there's lots of fluctuation, right? Every few years there's a new one coming. If you look at the DAX, it's very traditional. So where's the next Siemens? Where's the next SAP? So I think this would be something really important for the German ecosystem, to not only have great science, great translation, great startups, which are now more and more coming, but then also to translate into much bigger success stories that continue the tradition of German engineering and industry.
Yeah. Torsten, as you know both sides, so you live in the US and working for a US company, but you did some research, or you are a German researcher, and you were formerly professor at Karlsruhe Institute of Technology. What would you say? Is it in the US more easy to bring research to industry, or what differences do you see between US and Germany?
Fantastic question. I think the two ecosystems, and like Sami was just saying, the startup system in Germany is becoming significantly better than what it used to be. But these ecosystems, they work differently. And I'm not saying one is better than the other. They're different. And I'm probably not sharing anything surprising here, one of the ingredients that you have, especially in the San Francisco Bay Area, is that you have very good venture capital companies that are not only have the funding, but they also have the expertise to see, okay, what is the right bet to go after. And that is something we don't have at this scale here in Germany. And obviously, there are many failures as well that many people don't even talk about. But the few successes that then remain are the new Siemenses, the new SAPs that you were asking for. And this is certainly something that I sense is getting better here in Europe, but we still have room to improve. If I can add one other thing, you mentioned SMEs. What I would like to recommend to all SMEs here in the audience, to start playing with these systems. Create an account, be it with OpenAI, be it with Google, be it with Microsoft, and just start playing and start to understand how these systems work, and see how they can benefit your company, be it with administrative processes, be it in the space of robotics, be it in another a business process, whatever it may be. There's going to be a huge benefit that it's going to be a low-hanging fruit for many companies. And the sooner you start with that, the more you can benefit from it.
In Germany we say gute Fee. I'm sorry, I don't know the English word for that.
A good ferry? I don't know.
Yeah. If I was a good ferry, what wish would you have to bring the robotics research and industry in Germany, as you are in Munich based? So, would you like to have more money from the government, or not so much regulation as EU is discussing about an AI regulation? So
it's not discussing, right? It went through the parliament.
Yeah, okay.
So it's there. So let's ask. Yeah. I think that's a very great question, because there's many things I would like to ask for, but we also need to deliver, right? So we should not always just ask for new things without delivering. So I think it's super important that we show best practices and how things really get implemented. This is why automatica is so important, that robotics technology, AI technology come together and really show things that work and are meaningful, and not just just for the sake of doing it and putting AI on top of it. So I think this is one thing, and I can see this happening, right, more and more. So let's assume that we're doing a good job in, robotics is worth to be supported, yeah. And if we do that, I think it's really not only the science support. We obviously are a small country. Germany is small. We're not the US. We are not a united Europe, right? It's very troubling times at the moment. So it's even more important that in Germany, the roboticists work together and do something meaningful for the good of the entire nation. I think that's one thing I would like to put forward. So this goes to the national government. I think they would do a very good job to support the ecosystem in Germany, not only in Bavaria or Munich, to drive that. On the second part, I really think what is missing, and I said that already, is really this kind of, robotics OEM, German robotics OEM that can really, make robotics and maybe on the systems side. So if the software business is really tremendously being played in the US and there should be collaborations, I think we're missing this. And it would also help the science community to channel their efforts. So we're doing lots of collaborations with Siemens, with SAP, with Airbus, and so on and so forth. But I think it would be really important to build a robotics industry, a true one in Germany, again, that is super powerful to translate these things that we're doing. So that would be something I would be really hoping for, and make it easy for science and young, especially talents, of which we have far too few. We need much bigger programs to have more talents, to channel them into the industry and into the society to produce something. So that's my biggest wish, and this hopefully comes with not only industrial robotics, but also going to other domains such as healthcare, where I think we could do a tremendous job to support society. Yeah.
Great. Thank you very much. I would like to use our last 5 minutes maybe to open the discussion to the audience. So any questions here that are not answered right now? Oh, there's one. I come with the microphone.
Hi, Armin. Professor Haddadin, thank you very much. Is that you about the last topic?
A bit closer.
My name is Andrea Alboni from Universal Robots. I am Italian, living in Germany, heading a Danish company. So I'm extremely European. This topic about uniting force on a German level, on a European level, is just a wish, is a dream, or you see also the possibility to execute something like that?
Oh, that's a great question. Oh. Yeah, I mean, first of all, he was asking. I was asked to answer the ferry, right? So obviously, I would love this to be reality, and I think it would be great to do it. So why should there not be the possibility to do that? You need to put the right people together and create something of that kind. The question is always who sits on the table, right? And I think it would be the greatest thing we could do as a robotics community. Of course, I would love to see that. Absolutely, absolutely. I'm a true believer in collaboration and the European idea. I also think of myself of being a true European, and so I like the characteristics you pointed out very much. But it's also kind of our biggest hurdle, right, in Europe, that we are so diverse. We speak so many languages, and we also are proud of our national heritages. So I think it's always the same hurdle. So what would unite us, I think, very strongly would also be the regulation. If this could be a supportive regulation of European technology, I think many people could gather behind that and try to do a strong push to make robotics much bigger, right? So I think this actually needs more than just one of the players. Absolutely, yeah. No answer, but my very sincere position on that.
Okay, great. Oh, there's one question. So I take this question here, and then we go to the next topic.
Thank you. Your talk inspires many people, I think, to pursue some more dynamic paths in their production line, for example. We already see some change in how things are produced nowadays. Like there is a flow of how can I say it? Like we are used to the flow of information, but now it seems like we need to we are facing the flow of programs. Like, for example, Intrinsics. You see the tree, the behavior tree, and you could imagine that that tree might be in a flow of dynamic adjustment. Like, you have some different environment, and then you're able to dynamically adjust that tree, which can't be safely done within some microscopic code fragment or similar. So this feels like you can learn this stuff. What's your take on this? Is this the close future, or are we seeing this more down the line in the real world, like not the scientific world?
So it's a good question, thank you. Overall, it is indeed a new paradigm in the sense that when you look at the industrial robotics way of programming applications, you have like pre-planned motions, and it's very challenging actually to add like sensors, be it a camera, be it a force torque sensor, distance sensor, or even a simple light barrier. And now with the new paradigms that are coming up that we were showing in flow state, for example, you can add these sensors, and the demo that I was showing earlier, everything is sensor-based. There's nothing pre-planned anymore, and the system can react deterministically in real time, in like one control cycle, in a millisecond, to a new sensor event, and therefore be just way smarter, and you can implement new applications that are challenging to implement, have been challenging to implement so far. To the behavior tree question, I don't see a reason to do this dynamically. You can actually just have a larger behavior tree, and then you kind of, the path you take through the tree just changes during runtime. You could also, to your point, do this, change the behavior tree during runtime, but you basically then have a behavior tree on top of a behavior tree, which you can do, but it's pretty ugly. So that I don't think that there's a reason to move away from the behavior tree concept.
Okay, thank you very much. There was a question, but I'm so sorry. Unfortunately, we're running out of time. So if you have more questions to these guys, try to catch them. They are both in hall B4 with Intrinsic and with the Munich I. And if you don't catch these guys, catch them, one of their colleagues, and ask them. So thank you very much. Give them the big applause, please. Thank you. Thank you very much for taking some time.
Thank you, Armin.
Thank you. And great. So it couldn't fit better because on two reasons. First, this guy is not, Professor Sami Haddadin is not only professor at TU München, but he's also the father of the cobot Franca Emica. So, and we have a real user of your cobot right now. And you said before, I don't know who of you has said that, but you said, well, I would like to the SMEs to use the technology, to play around with it and use it.
That was him.
Yeah. So the next guy did it. So it's Elias Hohlocher, handcrafting.